Okay, so you're going to need to know how to do it all different ways. You don't want to be stuck on one different way to find the quadratic formula. To solve a quadratic equation. You want to be able to do it all. Want to be able to do it all different ways. Okay, so the first method that we use, Mr. Roden wanted you to use factoring. Okay, now many teachers teach factoring slightly different. Okay. Sometimes in high school, a lot of times, I don't know if Miss Wilson did it this way, they do the X and stuff like that, or the Punnett squares. Yeah. Sometimes they'll do Punnett squares. I don't do any of this. I just don't. What I'm doing is exactly you would be putting things into these Punnett squares and things like that. I just do factoring by grouping, okay? It's just a good old-fashioned way to factor by grouping. So the first thing you're going to do when you factor by grouping is you want to multiply the first thing times the last thing, okay? So in this case, 5k squared times negative 7 is negative 35k squared. Now, that's the product. This is a product. So what you want to do is you want to find two factors that sum to negative 35. Now think about the factors of negative 35. You could have 1 times negative 35, 1 plus negative 35. That multiplies to give you that, right? You could also have negative 1 time, I'll put these are times, sorry, times positive 35. You could also have a positive 5 times a negative 7, or you could have a negative 5 times a positive 7. So remember, we're getting these factors to try to add up to this middle B coefficient here. So which one, guys, is going to add up to negative 2k? 5 times negative 7. So this is the factor pair that you want to use. And all we're going to do is use substitution. We're not doing any magic here. We're just doing substitution. So I have 5k squared plus 5k minus 7k minus 7 equals 0. Remember, guys, negative 2k is the same as 5k minus 7k. It's just a substitution move. You guys see that? Now, why would we ever want to do this? Well, then we can factor by grouping. Factoring by grouping is often done when you have 4 terms. Okay? All right. Well, the first thing we're going to do is we're going to find the greatest common factor of the first set of parentheses. Well, the greatest common factor of 5k squared and 5k is just 5k. Okay? So we'll pull out that, and then we want to, now notice we have a positive. So we're going to want to pull out a negative out of here also. Do you guys see that? And what is the greatest common factor of negative 7k and negative 7? Let's pull out a negative 7. Okay? And then we'll just work backwards. Okay? So 5k times 5 times what gives me 5k squared? Well, just k, right? 5k times what gives me 5k? Well, just 1. See that? Negative 7 times what gives me negative 7k? K. Negative 7 times what gives me negative 7? Positive 1. Now, if this can factor by grouping, if it's a factorable quadratic equation, then you can factor out, you'll get two identical factors. In this case, our two identical factors are k plus 1. So we'll factor out those k plus 1s. When you factor those out, they are gone. You just factor one of them out. The other factor is going to be what's left over. Well, what's left over? 5k minus 7. And this still equals 0. Now, why do we prefer this is called factored form. Okay? This is factored form. Factored form, okay, of a quadratic equation. This is standard form. This is standard form. Okay. Now, a couple things I want to talk about. Factored form is nice because we can use what we call the zero product property rule. Okay? The zero product property rule is zero product property rule is if you call it's if A times B equals 0, then either A has to equal 0 or B has to be 0. So this is a factored thing. You have to have something times something. That's why we factor, so we could use this very easy product, the zero product property rule. So we'll just set these factors equal to 0. So we have K plus 1 equals 0, and we have 5K minus 7 equals 0. So we'll subtract 1 from both sides, and one of our solutions will be K equals negative 1. This one will add 7, and then we'll divide by 5. So that's going to give us K equals 7/5. Okay? And don't change things to improper fractions or decimals. I mean, mixed numbers and decimals. That's just ridiculous. Leave them as improper fractions. Okay? You guys got that? Any questions? Okay. So factoring is my preferred method, but it requires a quadratic to be a factorable problem. Okay? Not all quadratics factor. So if it doesn't factor, then you can use what we call completing the square. Okay, completing the square by far is probably the longest and most complicated, but as we see, you will need to know how to complete the square on this, and then I'm going to give you a problem probably on the test where you have to complete the square to write the equation. You guys understand that? There was delta math on that, so I think I'm going to do that. Yes, sir?
So if it's the most complex, why don't we just use the quadratic equation?
Because you can't use a quadratic equation to complete the square with a circle equation, right? So there's times when you have to complete the square. Plus, in math, you got to understand math, we never want things to just be magical. The quadratic equation is completing the square. Do you guys understand that? It's just derived by completing the square. If I had more time, I would show it to you, but I don't have enough time to do that. Okay. All right. So with that being said, let's go ahead and recopy this equation. What was our equation, class?
5K squared minus 2K minus 7 equals 0.
5K squared minus 5K.
Good job, Fran.
5K squared
Minus 7 equals 0.
minus 7 equals 0. Okay, now here's the deal. So what do you do when you complete the square? Well, the first thing that you do when you complete the square is you move the 7. You can do it either way. You can divide everything, but I'm going to move the 7 over to the other side. So I don't want this C here. I'm going to write this as a perfect square. So I'm going to move the 7 over to the other side. So I have 5K squared minus 2K plus my new C, whatever that is going to be, equals 7 plus my new C. So my goal is to get a new C. Now, don't do that yet. This new C thing, because I don't want to do that quite yet. Sorry. So the next thing I want to do, before I even think about my new C, I got to get that coefficient to be 1. So completing the square problems are harder when you have a number that's not a 1 in front of your A coefficient is not 1. And I'm purposely going to give you a harder problem because you're in geometry, you're double advanced math. All right, so we're going to divide everything by 5, everything by 5, everything by 5. Y'all see that? So when you complete the square, you got to make that A coefficient into a 1. If it's not, you got to do extra work for it. And then you're going to get, and this one's going to get a little bit of the ugly fractions. And this is when I said in the video, I just stopped it and said, I'm just going to do this when we get back. Okay, so now you have K squared minus 2/5 K plus whatever my new C is going to be equals 7/5 plus whatever my new C is going to be. I got to add that new C to both sides. Now, the whole thing about completing the square is you take your B coefficient. You got to do the one you just did. You're going to divide it by 2 and square it. You guys understand that? So my new C is you're going to take your B coefficient, you're going to divide it by 2, and you're going to square it. And that will make your quadratic equation into a perfect square quadratic equation. It just works out nicely. So, but the problem is we got some ugly numbers here. So B happens to be what, class? Negative 2/5. We're going to divide that, and I'm going to say 2 over 1, and then I'm going to square that answer. Y'all see that? When you divide, I call this a complex fraction. A complex fraction is a copy dot flip problem. So you copy the top, negative 2/5. You dot, and you flip the bottom, 1/2. Okay, see that? And we're still going to square that answer. Okay, now let's do the maths inside. Negative 2, this 2, that will cancel to a negative 1, and that will cancel to a positive 1. Y'all see that? So this is going to be negative 1/5 squared. See that? But negative 1/5 squared is positive 1/25. And that is your new C. Does everyone see what I did there? Any questions? Did I make a mistake? I don't think I did. Okay, so now we're going to take that 1/25 and we're going to add it to both sides. Y'all see that? Got to add that to both sides. Okay, now I'm going to just, can I get rid of this part right here, guys? Okay, I'm going to get rid of this just so I have some more room here. So you have it. I'm going to just get rid of it. Okay, is that okay? So now what I'm going to do is I'm just going to clean this up a little bit. Well, if you did, the reason you do completing the square is so you can write it as a perfect square. So let's take care of that. The way first of all, this sign in front of B always goes here. So in this case, it's going to be a minus. You guys see that? The square root of k squared is going to go here. That's going to be your k. And the square root of the new c is going to go here. What's the square root of 1 over 25, guys? 1/5. So you're back to 1, but it's a positive 1/5, right? Here, you got to get a common denominator. What's the common denominator between 7/5 and 1 over 25? 25. So we got to multiply this top and bottom by 5. Okay, see that? So this is going to be, let's just do a little, this is 35 over 25 plus 1 over 25. What's that going to be, class?
36/25.
That's a really nice fraction because they're 36 over 25. Okay, questions? Because I can square root it. See that? 36 and 25 are perfect square roots. Okay, now I'm going to keep going here. I want to get rid of this big power of 2. How do I get rid of this entire power of 2? Big square root on both sides. Big square root on both sides. I cannot tell you how many times I've tutored this concept over the last year. It's crazy. The high schoolers struggle with this really bad. Okay, so a lot of my tutoring things, like I'm going to teach my geometry class so they don't have to struggle with this. Question?
Okay. I lost you after we when did we square root it?
Because that's just the rule. Did you see what I added my new c to both sides?
Yeah.
Once you do that, it will always factor into a perfect square. A perfect square looks like this. This value is always just going to be your square root of your first thing, okay? And this is going to be the square root of your last thing. It's just the rule with completing the square. It just works out that way. And this sign is always going to be the sign in front of B. Sound good? Yes, sir. I don't know it yet. Gavin. Yep. Okay. Now, here we go. So now we're going to go ahead and once we take the square root, we have to do plus or minus. So now I have k minus 1/5 equals plus or minus. Hey, what's up? You bet. Right down back there, guys. K minus. Hey, it's our staff member of the day, guys. Excellent. All right. So k minus 1/5 equals plus or minus. Guys, what's the square root of 36 over 25?
6/5.
6/5, right? See that? So what are we going to do here? Well, this is going to come down to two different equations. And since this is an algebra problem, we're not going to throw out the negative. So now this is going to come down to k minus 1/5 equals positive 6/5. And we have another equation of k minus 1/5 equals negative 6/5. Y'all see that? And we're going to solve this by adding 1/5 to both sides. So we're taking 6/5 and we're adding 1/5 here. We're taking negative 6/5 and we're adding 1/5 here. Guys, what's 6/5 plus 1/5? 7/5. See that? Does that answer look like an answer we've gotten before? Yes, it does. What's negative 6/5 plus positive 1/5?
-1.
Negative 5/5. And what is negative 5/5?
-1.
Negative 1. Is that an answer that we have in our answers? Yes, those were our two solutions when we factored. Right there. See that? Okay, now, just so I was probably a little frustrating. Now we're doing the old quad formula. So we know the very fun song of x equals neg. I don't sing very well, but I did have a kid say, I think I have a pretty good voice. Okay, so let me sing this and see if you. I think I should try for quite here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's pretty good, right? Okay, so that was weird. Sorry, that was a little weird. So on this, you just have to make sure it's equal to 0. So, sorry, George, that was a little weird. So now we have a equals 5, b equals negative 2, and c equals negative 7. And I would highly recommend you write it out like that. I do. Now, I won't sing it to you again because that was weird. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, this formula just came by completing the square with a, b's, and c's without putting numbers in. You guys see that? All right, so now we're just going to go ahead and put numbers in. Instead of a b class, what am I going to put in? What? I'm going to put in a negative 2. And you got to be careful with your negatives. That's what kills you on the quadratic formula is your negatives. So now it's negative 2 plus or minus the square root of b squared. So negative 2 squared minus 4 times a, which is 5, times c, which is negative 7, all over 2a. So this is 2 times 5. Now, you've just got to be really careful with your negatives. That's what's going to get you on the quadratic formula. Everyone loves the quadratic formula, but I would say it's like a minefield of really particular work. So the quadratic formula, yeah, it's great, but if it's very detail oriented, you got to be really careful. Well, a negative 2 is a positive 2, plus or minus. Okay, here's where most of the mistakes happen in the quad formula, right in here, because negative 2 squared, that's 4, but you have a negative and a negative here. That's going to be a plus sign. I cannot tell you how many times kids don't switch the sign here. So we do the math here. Let's see here. What is this? 140? Yep, that looks great. And then we're going to say all over 10, right? Okay. And then, well, 140 plus 4 is 144, and that's a really good number, right? Because it's a square root. And then so we got the square root of 144 all over 10. Now this is what x equals. So then, well, square root of 144 is 12, right? So we get x equals 2 plus or minus 12 over 10. Now, if you want to kind of just do it this way, remember what's plus or minus? You're going to add once and you're going to subtract once. Guys, what's 2 plus 12? So this is going to be 14 over 10, which reduces to what? 7 over 5. We already have that answer. Then we're going to take 2 minus 12. What's 2 minus 12, class? Negative 10 over 10. And what is negative 10 over 10? Negative 1. Now, I said don't switch this, but it may, when we do our graphing, it may be 7 over, what is this? This is 1 2/5, right? Or 1.4, right? So that's probably a good number to remember when we graph it. So those are our two intercepts, our x-intercepts. Now, the last thing we're going to do is we're going to pull up our friend Desmos, or we're going to use our graphing calculator. So we're going to pull up Mr. Desmos, okay? You can see that Desmos, I used to always do graphing calculators. Now I just pretty much just do Desmos now. I like Desmos. I think it's actually a little, I just prefer it more, mainly because I can show it on my computer. All right, hit the graphing calculator. There we go. What was our equation, guys? So we'll just call it x. So 5. You could say y equals or not say y equals in Desmos. It doesn't matter really. So 5. So let's see here. So 5. You could even do k. You know what I like to do? Let me move this. Will this move? Yeah, actually, I can just do it on my keypad. So 5x, and I'll raise it to the. Let's see here. How do I shift it up? Shift 6. Shift 6. Squared, right? Right arrow. Go down. What was the next one? Minus what? Minus 2x. And then minus 7, right? So that's all you have to do. And, well, this is a parabola. We can definitely see that it's got solutions because it's crossing the x-axis. And let's scan in. Let's click on those. Does that look good? -1, 0? Yep. And does that look good right there? 1.40. Now, the bottom, that's called the vertex, right? If we wanted to find the vertex of it, we would have to, kind of missed that. We would have to probably do a different formula on that. Sound good? Okay.
There we go.
You'd use the vertex formula. Yep. A great way to do it is you would put it in vertex form. You would complete the square and put it in vertex form, right?
Yeah, there we go.
If you wanted to know what the vertex was, you'd complete the square and put it in vertex form. Yep. Any questions on that, guys? Okay.
Are we gonna play math basketball today?
Not today. There's not time. Okay. So I want to show you one other thing on the quadratic formula really quick. Okay. It's just such a powerful thing. Yeah, and a lot of you guys, quadratic formula, it's really powerful. So one thing I want you to put this in your notes somewhere. I will not test you over it on this time though, but I want you to put it in your notes. I don't want to give you a last minute test. But this part right here, and let's see if anyone can remember this because this is really important. This part of the quadratic formula is really, really important. Does anyone remember what it's the part underneath the square root. Does anyone remember what b squared minus 4ac is called? Okay, very good. So that's why we're going over this. So the b squared minus 4ac, the b squared minus 4ac is called the discriminant.
Oh yeah.
Now, if you just look at the discriminant, it's not going to tell you where your answers are, but what this does is it tells you how many solutions you have. Okay, so I'm going to say D for discriminant equals the b squared minus 4ac. You guys understand that? Now, this is a really good thing to remember. So if your discriminant, if you do the math and you put the numbers in and D is greater than 0, what that's telling you is you're going to have 2 real roots or 2 real solutions. Okay? That's what it's saying. If your answer underneath the square root is a positive number greater than 0, you're going to have 2 real solutions. Okay. Now, if your D can actually equal 0, you can actually do all the math and the whole thing is going to cancel out to 0. That means you're going to have 1 real solution. Okay. Now, if you're going to have, sometimes you get D is less than 0. Now think about what's happening there. You're taking the square root of a negative number. So this means that you're going to, so in a algebra 1 class, you would just say no real solutions. But since you guys are going into high school, what you're going to have is you're going to have 2 imaginary solutions. So what your high school teacher is going to do is they're going to talk about imaginary numbers. So in Algebra 1, you just stop there and say no real solutions, okay? In Algebra 2 that you're going to be in next year, your Algebra 2 teacher, you're going to start to talk about imaginary solutions. And they're really an easy concept. They sound really funky and weird. They're not. They're very simple, okay? And they don't really, but you get two imaginary solutions when that happens. Okay, so I don't want to go on too much about this because I want you guys to be able to ask some questions. So does anyone have any questions about the quiz right now? No, excuse me, the study guide, my bad. Does anyone have any questions about the study guide? Just give me the number. Let me pull up the study guide and I'll take a look. Okay, Austin. Wyatt. Sorry, Wyatt. Sorry, Wyatt. Go ahead.
No, but are you gonna post the video for the rest of it, or just?
I already posted the video.
Okay.
The only thing I didn't post was the quadratic part, right?
Okay, I didn't.
Okay, Sophia.
Could you do 10?
Number 10?
Did I understand how you explained it?
Yeah. Let me do 10. Yeah, and that's pretty interesting. So let me do into shape. Let me see if I can draw 10. So number 10 is a circle. This is number 10. Okay, let's try that again.
Use your shapes again. Shape school.
I'm gonna try it for. That's pretty good, right? Okay, so we got a circle. This is number 10. Okay, and it has. Let's see here. Let me just do this. Let me do my shapes. It has a diameter. How do I know this is a diameter?
It passes through the
Because it contains the center point. Whenever you see a dot in the middle, that's just assuming it's a diameter. And then it's going to do something like this. It's going to come down. Now, this may not look exactly, but it's going to look pretty close. Okay, I should maybe just copy and paste this one. Sorry. It's going to look something like this. Okay, I'm going to do this. This is ridiculous, Mr. Roden. This goes out like this. Okay. And this actually. Chris, you okay? Okay. All right. Next one, I'm gonna just. Okay. So this one goes like this. Sorry, bad drawing. This one goes like this. And then this one comes down like this. Okay. Sam, can we stop, please? Right in the middle of this. Okay, here we go. Now, we have this as right here. This is our x. And sorry, this is supposed to connect to the circle. You guys see the picture. This is y right here. There's a center point here. And we want to know, okay, so the question is asking, in the figure in the quadrilateral is inscribed in the circle. Find the value of x plus y. Okay, so here's the key. This angle right here is an inscribed angle. This guy right here. You see this angle? And what is its arc is a semicircle. Because, and why do I know that's a semicircle? Because it's a diameter. Now, we talked about it. What kind of inscribed angle is going to have an intercepted arc that is a diameter? It's going to be a right angle. So this must be a right angle. Does everyone understand why? That's the whole point of this problem. This has to be a right angle right here. It's got to be, because its intercepted arc is, I'll do it in blue right here. This intercepted arc right here in blue, this guy right here is a semicircle, and I know it's a semicircle because this is a diameter. So the key is knowing that that's a point, that's a diameter, that's a center point. You guys seeing this? Okay, once you know this is a right angle, you don't know what x and y is equal to, right? X and y could be multiple different angles. But x and y, what are they going to have to add up to, though?
90.
And why do they have to add up to 90, class? Because the triangle's 180. You already got 90 of them in that angle right there. So this plus this has to equal 90. Now, they could equal different things, right? But they got to equal 90. Okay, one could be 46 and one could be 44, right? Or whatever, but they have to add up to 90. Are there any questions on that? Sophia, does that make sense? Do you understand? Let me break this down, Sophia. Do you understand that this is a right angle? Okay. Do you understand that there's 180 degrees in a triangle?
Yeah.
Do you understand that 90 of them are already taken by this right angle right here?
Yeah, I just thought like the problem was asking to find like X and Y specific.
Nope, you can't, right? Because X could be 44 and 46. X could be 45, Y could be 45, right? They can change. There's multiple things X and Y can be. So you can't exactly say what they are, but you know their sum has to equal 180. I mean, excuse me, 90, my bad. Sorry, sound good? Questions? Okay, any other questions on this? Martin.
23.
Number 23. I should have just scanned this in. Okay, so 23. All right. 23 is gonna involve a secant and a 23 is gonna involve 23 is gonna involve a secant and a tangent. So the most important thing on this one is you have this formula ready to go. So here's the deal. So this shouldn't be quite as hard to draw. If I could do a good job. So we got a a tangent. There's a tangent, and then we got a secant. Okay, remember what a secant is? It's a line that crosses the circle twice. Okay, now we got this going on it. Okay, and so this part right here is 3. This part right here is 7, and you want to know X. So who can raise their hand and tell me what is the formula for finding? It's kind of a ratio type of deal. What is that, Xavier? Okay, so it's going to be so the whole length of the top one, so it's 10. Yep. Times the outside, which is 3, right? Equals X squared. So it's the tangent part squared equals the whole thing times the outside part. You guys understand that? You got to just know how that works. In this case, it's the tangent part squared equals the whole thing times the outside part. So this is going to be this is 30 equals X squared. We're going to square root both sides. This is a geometry problem, so I'm not going to worry about the negative. So X equals the square root of 30. Guys, is the square root of 30 reduced? Is there a perfect square inside 30? No, it's done. Square root of 30 is in reduced radical form. Got it? So this is the answer.
Wait, you put it in decimal. Yeah, you put it in a decimal.
Yeah. So maybe I took a next step. I'll take both. Yep. I just must have just in my head did it. Sometimes I'll be specific about what I want on the test. Sound good? Any other questions on this? George.
Question 20.
Number 20, George. Let's take a look at 20. Okay. All right. 20 is the thing about 20 is you have to remember at the very beginning when we started talking about tangent lines. Okay? So I got these two tangent lines doing this. Let's try to draw it. Okay? And so the key about this is, and I think it is in our notes somewhere. I can't remember what the date is. I'm going to try to find it. But when you have two tangent lines, okay, and then you have a central angle, okay, I think we're assuming this is a central angle, right? All right. So I believe that this angle here, the central angle, is supplementary to the intersecting point out here, okay? So these two angles are supplementary. So that's the key to know. This angle, the central angle, and I think that is a central angle, facing the angle of the tangent intersection, they're supplementary. So we can say x plus 65 equals 180. Guys, do we have that in our notes somewhere?
Yeah.
Cody, what does it say?
It says that opposite angles are equal to 180.
Right, they're supplementary. Opposite angles right there. Good. Is that what it says in your notes? Okay. And what date is that, Cody?
I did not write that.
Okay. Okay. So we subtract 65 from both sides, George. And what is that answer, guys? X equals what? 115. Okay. And that would make sense. Okay. Any other questions? Caitlin? Number 29. Okay. Yeah, 29 is a good one too. 29, actually, when I was doing 29, I had to scratch my head for a little while and say, whoa, what's going on here?
Whoa, yeah.
Okay,
Oh,
so
that
29,
one.
but with the problem with 29 is you have to kind of know what the parts of the picture are. So first of all, we've got a tangent line. Let me draw that. We draw the tangent line. So we got Mr. Tangent Line here. Okay. And then you've got some rays shooting out of the a point on the tangent line. So we'll go ahead and do that. So we'll do something like, it's not gonna, something like this. And then we got another ray shooting out, something like this. Oh, undo. Nope, not that. Okay, so something like this. All right. Now, here's what this is saying. So first of all, this, and I'm going to highlight it because it's kind of hard to see. This arc from here to here is equal to 126, okay? All right, 126. Now, this arc, and I'll do it in a different color. I'll do it in yellow. This arc from here to here, Caitlin, that's the 92. So that was a little confusing to me. It's not the angle measure, it's the arc measure. See that? And now, this is an X and this is a Y. Now, the X should be very easy. Okay, how can we figure out what the X is, class? Right, the X is an inscribed angle, so X is just going to be half of 126. Will, does that make sense?
Yeah.
Good. I would be listening right now. Okay, so half of 126 is what, guys? 53. Now, 63. So here's the problem that I had. I wanted to say, well, I thought this 92 is not an angle right here. It's this arc. So what's the relationship between the tangent line and the secant right here? It's half. You guys understand that? The angle is always half. So it's almost like an inscribed angle also. So this arc right here is 2 times this angle right here. So what is this angle right here, class? 46. Okay, now to find y, how would we find y now, guys? Right, it's angle addition postulate says we got a straight line from here to here, right? That's 180 degrees. So if we take 46 and we take 63 and we add y to that, what does that have to add up to? 180. And then it's just a bunch of math here, right? What's 46 plus 63? 109 plus y equals 180. And then we subtract 109 from both sides. And we get what? Y equals 71. And we're done. Okay? Caitlin, does that make sense? What was it, the arc, that yellow arc that got you? That's what got me on this problem because I wasn't reading it correctly. Yeah. Okay. Excellent. All right, Mr. Martin, you got another one?
28.
Number 28.
Oh, yeah, 28 was a tough one.
Okay. Number 28. Good problem here. So let me do into shape. Got a circle. Not too bad. Not too bad. And then we've got just a chord right here. Let me just draw a chord there. Get rid of this. Got a circle, then we got a chord. Okay, going across. Not too bad, not too bad. And then we've got, and I'll just freehand this part. We got a little, we got the center point, which is always good. Center point, we got down here, and then we got over here. And then we know that the radius, okay, is 3, and we want to know how long x is right here. So here's the deal. We want to know how long the x is, right? Okay. Well, this is a right angle right here, right?
Right.
So this is bisecting this. This is a perpendicular bisector right here. Do you guys see that? So if we figure out, let's say, we'll call this C here, right? Then we can figure out, we can multiply that by 2. Now, how would we do that? How would we do that? Well, oh, by the way, this is 1, right? So we can use Pythagorean theorem. So a squared, 1 squared plus c squared equals 3 squared. So 1 squared, 1 plus c squared equals 9. And then so c squared equals 8, right? Square root both sides. So c, when you just take the square root of 8, is 2 square roots of 2, right? Okay, now that's half of it though. That's 2 square roots of 2, right? So what would x be? X is all the way across. Times it by 2. So x is going to equal 4 square roots of 2 or whatever that is in the calculator. And you're done. Sound good? So my guess is I'll have you round everything to the 10th place. So finish that off for me. What is 4 square roots of 2? Approximately 5.7. I will not stress too much over decimal points. That's why I like to have paper tests, so I can make the final decision, not Schoology. Okay?
5.8 would be fine.
5.8, 5.7. Yeah, I will not. Bye, Nicole. Okay. Are there any other questions? All right. So I'm going to go ahead and end the video now, and I'm going to save it. If you want to go